So this is round two of some of the discussions we've been having about ontologies and an automated workflow. And before we get to that though, because I love to massage information slowly into your brain over time, we'll start with a little bit of a warm up, namely the murder mystery. I remind you, a psychologist has been murdered. Dun, dun, dun. The usual suspects are listed here. We all know it was Werner, but let's prove it. Just kidding. And she's like, wait a second, I've already solved this. What do you see? Here is the task here being to represent these facts in protege and then create, as a pro tip, a murder class that is equivalent to line 9. And then if you do this correctly, protege reason, or I should say something like hermit, will result in exactly one member being an instance of the class murderer when you run it. So go forth, solve it. And if you've already solved it, raise your hand and I will come destroy you. In protege, yeah. Oh, you're just doing it in your head. I mean, yeah, obviously we figured this out pretty quickly. The task is protege.
Your stuff, I think. Is it under LFO?
No. I deliberately did not capture.
Off the top of my hand, but let's see, GitHub.
I could use it.
Not astronomy. Clue game 2 or clue game?
Yeah, it would have been Clue Game 2.
All right.
The zebra puzzle was the other one that we did.
All right.
Sorry, my naming conventions aren't great.
But you say you're sharing now, okay?
I am sharing, yes.
Because I'm too slow. Sorry about that.
No, that's good. He said clue, and I pulled it up immediately.
Okay.
Okay, can you see my screen?
Hold on.
It doesn't tell me which screen is sharing, so let me stop sharing and try again.
I can't even. Okay. I see your protege.
You see my protege, fantastic.
Yeah.
Okay. This is what we had. I think the last thing we did was pop in all this stuff.
Okay.
I remember we were talking about
make them individuals or instances.
Instances, but last thing was using object properties versus data properties.
Okay, and we didn't like the does and does not, right? Because it was.
Yeah, I think there was something weird about that.
Yep. So we were moving the object properties over to data properties and changing does not because that was too limiting. So
yeah, it was pretty exclusionary, if that's even a word. Let's see, where was I? This is data properties problem solves.
You tell me. I think so.
Or was it that we were changing the hobbies to data properties instead of we were changing all these things to be data properties. That's what it was.
Yeah.
Or no?
I think so.
Okay,
that makes sense to me.
How did we feel about the music and not music?
We didn't like the not music because it was too exclusionary, right?
Right.
Right. So it was like plays music and has another hobby.
So okay.
So we didn't like that because they were instances, right? So problem solves, plays music, reads, daydreams.
Okay, let me read these things again. I don't know if you guys can see them. I'm just going to whip them in front real quick. Okay, so.
We're talking about.
Yeah, I know. But
did we create a murder class?
Yes, we created a murder class.
So I'm now the material entities, namely the electric field. Because particles change, and I can ideally get the same electricity upright or the same.
Sorry, I'm thinking for a sec.
Sure, electrical charge. So,
Well, that's amazing.
isn't there a?
Why don't we go through and figure out what we don't have, right?
Right,
Maybe that will at least get us moving and the brain juice is flowing.
yeah,
At the same time.
screenshots,
I mean,
pull that back up.
So I
Okay.
have a screenshot of
Yeah.
it. So do we have
So-
Sorry.
Suspects, Warner, Mark, Neil, and Barry.
Yep.
Instances,
But with another measurement, broader. scale.
murder class. Okay, Mark plays violins. We have all the different instruments. So do we just want to say hobby and then hobby is like there's a subclass of hobby that's music and then there's the other two instead of not music?
So I thought we're gonna avoid using
Oh.
the classes and go to, the data properties, right?
Right, data
Um,
properties.
And then add these.
So data properties being for the instruments or for the hobbies, not for the
Yeah, for
people.
the hobbies. So like, violin, plays violin, daydream, right? Is that what we
Yeah.
daydream?
Thank you. Not being able to
Reads,
crowd.
solves problems. We have that.
Read.
Music. So we have someone, or actually, we have someone who cannot play music.
I was surprised that she was here.
Not music.
I don't do it.
Oh, but we didn't like that for some reason.
Okay, so
We'll come back to it. How about that?
read,
Trumpet.
violin, problem solve, trumpet.
Except right here. When I was training for America,
And
every morning I would wake up, and it was because I
what's the
didn't
other one? Daydream, problem solve, daydream.
start running 12.
We have daydream, oral, but
Violin. Nope, violin, read. Am I
we have
crazy?
violin.
Yeah, okay.
And
I think that's it.
then yeah,
1, 2, 3, 4, 5. Yeah. Okay, so
Don't
should
we
I
wanna
just
get
delete
rid of-
these?
what?
Should I just delete these then?
I don't know because we have equivalent to, or do we want to make sure we follow those? Can we bring them over before we delete them, or?
I go over one line.
Like it needs to know
So
that.
there is new.
It needs to know
quality
that like
of
Barry,
triangle
Mark, Barry,
shape.
Warner.
Will they all?
New order has changed,
You
so it cannot.
gotta-
With a dependent even.
I already did it since I can help you.
There is a new-
What was it? Did we do something with general axioms last time? Is that what he was bringing up?
I don't remember
No.
that.
No, there wasn't.
So we did instances of hobby, right? Can't we pull that up in the hobby?
Yeah, so the instances of hobby were these things here. So we had
But
object.
if we're getting,
Sorry, we had individuals.
Is that the class?
So do I remove the hobbies from individuals?
Trying to press.
I don't know. I'll be honest that, John, you have any insight here? Like,
What's up?
not you, the other John. Sorry, we'll call you Professor John.
Got it, Professor John.
No, not necessarily. I mean, I'm just kind of trying to follow what you guys are doing here.
Okay, we're struggling. That's what we're doing, I think.
Yeah.
All right, Professor John.
Yeah, okay. What's up?
Yeah.
Hey, so we're struggling. We're stuck. So if you want to start the class, Matilda, right? So we started doing hobby, murder, suspect, murder and suspect, and then we were in object properties. Right? Does not. And we decided we're going to move away from this into the data properties.
Yeah.
But we also have them as individuals, and so now we're sort of straddling two approaches, and we're not sure. We could use a little
Guidance.
Yeah. So the individuals that I would use here are just Werner, Mark, Neil, and Barry.
Okay, so the actual individual people.
So we move those back under the data properties, right?
No. So those would be the individuals. Oh, you mean you're the ones you've highlighted? You would move. Yeah, that's right.
Yeah.
And then so I wouldn't have murderer X. But if you did, it should end up being, it should have all and only the properties that whoever among the others have, and it will be the same individual under the class murder. So it
Okay, but we don't need to create an individual
technically
called
don't
murder.
need it. You need a class.
We have the
Okay.
class, yeah.
Okay, perfect. And so then for the data type property, move, what I'm saying is you have a data type property with a Boolean, like a Boolean type data property that says things like plays violin. And what you'll do is you'll tag, say, if you're looking at 2, that to Mark, you'll say Mark data type property plays violin, and then you'll say true. And then that is a way to capture 2. And remember, this is like you're capturing the facts and you're not trying to reason over at any point, his specific violin, right?
Okay. And so to do that, it's domains, right? And then I would have to say like true or false.
So in this case, here, I will walk you through it. So let's introduce a data type property, just a new one called plays. Or even like plays, let's see, plays music.
Okay.
Okay. And so this, you will say, if you open that back up and click on annotations again. It's on the right, to your right.
Oh, annotation.
No. Like the little green box. That
Directly
says,
to your right. Yep.
if you click on
Annotations.
that
Okay.
plus sign, okay, and then you click on, let's see, if you go to property values, or yeah, I'm looking for where you put in the range. So
Could
data.
I not put range here? Is
Oh,
this
there you
different
go.
than-
That's what I was looking for. I'm sorry.
Oh, okay. You're good. So
Range.
range.
Go to built-in data types. And then look
Oh.
for Boolean.
No, I would make.
Yeah, there you go.
And whatever the other one is.
And then click OK. And so what this says is that anything like this only links up to true or false. So
Okay.
you put in the range.
Okay.
And so you will have, if I'm just looking here, I will have something like daydreams, true or false, reads, true or false, problem solver, true or false.
Okay.
Then I can say things like when I want to capture 5, like Werner never daydreams. I will say Werner daydreams false.
Okay.
And then, but then like some of the trick to this is that you have like with the playing, like plays music. I said plays music on purpose for the following reasons. Like if you're thinking too much about the facts, you'll think I need to put in a violin. I need to put in a trumpet.
Yeah.
And then, but if you look down at 9, it doesn't say anything about the musician or like the actual
Right.
musical instrument. So you don't really need that information. You just need to know that they play. And so hence play music. Does that make sense?
Okay. So
Oh.
do I even need to define trumpet or violin? For all the rest of them, I could just say they play music or they don't play music.
Right.
Oh, fantastic.
Right. And as like another pro tip here. So you're trying to infer information that's stored essentially in 9. Right? Like that's the base you need. And so what you need is exactly that. You need murder, you need something that indicates murder, something that indicates they daydream or are a musician or read and they solve problems. Now, when you're looking through the rest of the list, the only reason you would need to introduce anything other than exactly what 9 is saying is if you needed something like that as a stepping stone to get to daydreaming or music playing or literature or problem solving, right? But if you
Okay.
don't, in this case, you don't actually need extra steps. All you have to do is kind of represent exactly those facts. Does that make sense?
Okay.
Mhm.
Okay. No, that makes sense.
Awesome.
Starting with 9.
Great. Dr.
Okay.
John Away. Professor John Away.
Okay. So play music, true or false,
Yep.
Boolean, problem solve. I wish I could change the name of this easily.
Refer to everything. It's inconsistent.
What'd you say? I didn't understand your question.
Oh, sorry. I wish I could change like this name really easily.
You have an inconsistency, and inconsistency will not even.
Okay.
But you
read
could, I
true
mean,
or
you just
false.
change the annotation, but, right?
Yes. Oh yeah. Yeah.
Just change it to an RDF's label and then it'll be whatever you want.
Okay. Plays music.
For anything useful.
Daydream.
So I think.
Reads. Solves, problem solves. Okay.
Is it necessary to create?
So then I could go.
Like a
Wait
murder.
a second. Okay.
That murder.
Now, would I put in all those assertions here? Property assertions for Neil,
Each individual.
each individual, or like what's the point of doing this then? Or like, I don't need this
Those are
hobby then.
I don't think we need the music, not music, right? Well, I think we do need the hobby because that's the class, right?
Gotta have somebody's killed, right? Like,
Right, so we have the
Okay.
classes.
I mean,
Maybe we don't need them because we
I
have
don't
the,
think we need it.
murderer,
it's aggressive, but okay.
Killed someone.
Okay, you know,
We have like two murderers and like one is murdering like this guy and.
because I feel like we account for them as individuals and data properties. Maybe I'm losing
Go
it,
for
you
it, let's
know?
give it a shot. I get what you're
Okay.
saying.
Object
It's not
properties.
crazy.
Like, oh, and so then murderer has like
10 and 9.
could be,
Even in the game.
would it be then murderer is not equivalent to, but could be like
Four.
any of these four?
Yes.
Yeah, it would be this. So it wouldn't be, oh, suspect. I already have suspect. Murderer, suspect. I'll just change the name of this. I'll delete this. Is some suspect. Okay, subclass of.
But no, didn't we need to bounce it off, right?
Well, technically, we put suspect in first, and that was our murderer class.
Oh, okay.
Oh shit! What did I say? It's some.
Suspect.
Is that how I wrote it? No.
Just you could copy it, so go over it.
Oh, I did. It did work.
Okay.
Okay, perfect.
So far, you got.
Delete,
Did we?
and
Oh.
then I'm gonna change IRI murder just to match what his method.
Yep.
Okay, there you go. Murder is some murder equivalent to this, or this.
Yep.
I don't think we need the instances of. Maybe that ties into this, but I'm not entirely sure how Protege works, so we're gonna leave it at that for now.
Yep.
Individuals, it's probably
Classes you should use.
object.
So we don't know if he's literally.
See, but here then, because it's an instance, it calls it like it is a type of murder.
You can't play music, you can't read. That's
Yeah,
right.
it's done.
Yeah, no,
You
you
never get a murder.
I don't know. Why are we
What happens if I
deleting?
delete?
Just you solve problems.
Why are we deleting? Because isn't it one of those instances?
Oh Jesus!
You
Protege,
can
that's
undo.
just me
Don't.
now.
You can just undo.
No, it's just that it's
Oh.
glitching on me.
It's Protege.
Mark creates problems. That's right. Dave, no, you got, Dave.
Dave.
Good, he is a daydreamer. Musician, he does play.
People murder.
Not a trumpet.
Okay, one second. I'm gonna
Yep, sure.
open this
Take
back up.
No,
Who this is supposed to represent? Is he literate?
Well, I'm already open to the tab.
Can he read?
Okay, well, I feel like we're much closer already.
I think we're learning.
Harry solves problems to shout. Is a musician. Nope.
Where did you pop up?
He can't play music, but he reads himself. Reads.
There.
But thinking.
Oops.
Classes, oh, for subclasses.
Okay, yep, okay.
It usually open. Yeah, exactly.
I could just, we're just gonna delete,
Okay.
re-edit in, right?
Back over here. Data properties, individuals.
No, it's fine. All I have for people is just the four.
They will be.
Now we put these in as data properties,
Data
so
properties,
data
yeah.
property assertions. So
So let me get back to the Barry. Who are we doing?
right.
Barry.
Photo. Let's start with Mark plays violin.
Okay.
Mark.
Mark. Yep. Violin. Mark
Mark.
daydreams.
Mark. Data property assertions. Violin. So he does play music.
Yep.
True. I don't know how
How to represent that?
to
but that-
represent. Is it true, false? Can I just say that? Does it recognize that?
I don't know. Let's give it a shot.
Okay. Mark plays violin. Neil, Mark, and Barry daydream. So
Yep, Mark
daydream
also.
true.
Yep.
Maybe
Maybe. Neil and Barry.
Okay.
Neil
whenever I see these URI,
daydream true.
Yep.
at the moment.
And then Barry daydream true.
Yep.
You want to make an ontology?
Okay. Barry cannot play music. Barry. Barry music false.
Yep.
Read true, solve problem true. Read true. Solve problem true.
Oh, you can just.
Warner never daydreams. Oh no. Oops. Daydream false. Mark doesn't problem solve. Problem solve false.
You still have the rise.
Ooh. Why did I go back over? Individuals. Mark. Problem solves false. I feel like this is not, I don't know. What do I know? Warner
I'm
plays true,
Googling it. It
plays
says
music.
like we have to put in a Boolean value.
Yeah,
it-
but like,
parent-
so how do I
Are
type
we
it?
putting it in parentheses? Try parentheses. Open one up and see if it changes.
That makes so much more sense.
Or like quotations according to ChatGPT. See if that works, if that changes it.
I'm just gonna do PPL.
Is it that thing where, excuse me, I'm gonna
You
go
can
back over
type
here.
it
Is it
out
the
and have-
same as this one?
Yeah, it's sort of like that. Where
Okay.
if it's possible, it'll come back up.
Parentheses
Wait, how do I
and then
take?
brackets.
Just go ahead.
So
You can read, you can check one.
parentheses and then brackets. False.
Did it change anything?
What did I see? Oh, it's now a
Okay, so maybe we need
Maybe?
to use quotation marks rather than brackets. Let's try that.
So, reads, you saying. We got it back. You said
interesting.
problems or equations.
Do you guys see what I'm looking at?
I typed, actually, did.
Why is the backslash?
Because you have parentheses in the first one and there's double quotations in the second. I'm not sure which one is right over the other. John, any
Yeah.
thought?
No, I would maybe try to switch one and see if it works. Like maybe put the parentheses around true, see if that works. If not, then remove them.
Or.
That's what I did, but it changed to this.
Okay, let's see. I'm just gonna quick Google myself. Protege, defining property. Search.
Or moving like that. Whenever somebody says something now, I don't believe it, it's like.
For individuals.
No, my wife is away for a week.
Equals true? Like, I don't.
I told my wife that I let her watch TV and dinner every night.
Give it a shot. We'll see if it comes up for Daydream. Which one? Because it's
Because she thought I did. Yeah, she was like,
true.
text me. No, of course I
No.
didn't.
Oh, no.
Well, she said.
Can we go to go to the oh, you're there. Maybe do it in the data properties. Maybe we're doing it in the wrong place.
I am just.
Oh, you mean in here?
I don't know. I'm trying to, yeah.
Yeah, I know, right?
If we're trying to do domains and range, right?
When I was
I don't know. I'm I'm spitballing at this point because I'm not sure. Doesn't sound right. I know.
Right, there we go.
I did this.
You should ask yourself that every step of the process, right? Like, why would I ask?
Data property assertions, negative data property assertions. What is a negative data property assertion?
The opposite of the data property assertion, right?
Yes.
Takes time and effort and labor.
Negative.
I know why.
Okay.
Can't just because somebody told you.
uh,
It needs to be a comprehensive analysis. Otherwise, we'd be building all sorts of projects.
Just give me a sec.
I'm trying to get it.
Are we all Googling at the same
Yes.
time?
Curious. String walk through. Okay. We've already defined it. There's a plus button. We already did that.
So, this is my. In order
Find
to.
the data property.
What is the specific problem we're trying to solve here?
So the specific problem we're trying to solve is we're trying to tie data properties to the individuals, instances of Barry, Mark, Neil, and Werner, by doing a Boolean range true or false in terms of what their hobbies are either are or not under the class of murder. Is that right, Matilda?
Yeah. Well, yeah. We're just trying to know what the syntax is for like typing this up. How do we get the program to understand that we are assigning it a Boolean value of true? Do we just type true? Is there a specific syntax that we need to follow? Like,
All I need is to represent.
So I have here, I'll drop this in chat, right? So this, I mean, I think we're close, right? So if you has response, meaning like equivalent of play music, and it's data type, and we're in the data type.
You look at line 9.
Right, and then it has response and it's true. Try that syntax. You see that?
I don't actually, because it's giving me this funny link. Is this what you're looking at?
Oh.
No. I hope
Okay.
not.
That's
Do you see it
that's
in
the
the
link
chat?
that's the link I clicked.
Don't click on it.
Oh.
Just
Oops.
look at it.
Sorry about that.
No.
Chat has response data type.
Right. So has response is our equivalent, I think, of plays music, and then you have like a weird, greater than, and then equals true. You see that?
You mean this?
Yeah.
Okay. So wait, which one's true? Plays music true.
Plays a violin.
And it's on both sides. Yeah, you got it. I don't know if that's true. It doesn't look right.
And plays music for
Anybody who's
cancel, so Control C.
False? The reverse?
Yeah. I don't think that's right.
You don't know anything else.
Yeah.
But choose there as a way to.
Okay.
Plays music.
Really, you should read this from the bottom.
Okay.
Open and then Control.
Dang. Okay.
Daydreams. Musicians. It's
Back to
almost.
Google.
Yeah, back to Google. We can.
I'm gonna just type in true false for whatever. And if we even need to change the syntax, then I can just run through and do that real quick. Does that work?
Maybe we need to put it like its value. Just put true, right? Let's leave that there.
Yeah.
Because that's what I'm getting most is like it's true, false, true, false, true, false.
Mark.
We can come
Does he
back and
play
fix it
music?
if there's.
Mark plays violin true. Okay, so that was true. Mark is true. He does daydream. Just because I was screwing around, I want to make sure I didn't like reverse any of them. Mark does not problem solve.
Cancels problems true. Which is
Mark does not problem. Yeah.
Okay, so we were at 6 then. Fantastic. Barry, yeah, okay, so or Werner never daydreams, right? Okay, so 7. Werner plays music and problem solves. Plays music, true.
I mean, I would frame it.
Problem solve, true.
gonna say murders are gonna go, but turn you
So what it did.
Okay, Neil, no music,
Neil
no
cannot play
reading.
music, cannot read.
Okay. Why don't you pop over there and see if they can give you a hand? Okay.
And he doesn't read?
He does not read.
Okay.
I didn't get any.
He does daydream.
Yeah, because we have that. And now the murderer.
The murderer daydreams.
So, perfect. Yeah, you got.
How do I say that? Because he said we don't need to have an individual, which is like suspect. So like,
We tag
where
it
would my
black.
input?
Did you just?
General class axioms.
Professor
Hello.
Khan.
How's it going?
So just
Oof.
want to check.
Uh,
Is this how we're supposed to input this?
That is right.
It is right?
That is right. Now, are the specifics right? I'm just gonna assume. I'm not looking at them.
Yeah.
Right. Yeah. Yeah. We just wanted to syntax like us just typing true and false.
Yeah.
Here would
enough.
work. Okay.
Check this out. So run the reasoner.
Oh, so we were gonna try to.
Yeah. Now go over to classes and click on murderer. Okay. So scroll down a little bit. Okay. So the thing is that you have asserted that murderer is equivalent to one of these folks.
Mm-hmm.
Now, you've also asserted that it is a subclass of some murderer. So
Oh,
I
this is a leftover from last class, so I'm not actually sure if that's correct.
go ahead and click that.
Remove.
Yep.
Okay,
Now,
cool.
here's the thing. So, and you'll see it did some like rerunning. I guess.
Ordering, yeah.
Yeah. So here's the thing. So, murderer is, I suppose, in a sense, you have not said anything false, but you've also you've not provided the reasoner any link into inferring anything more about the murderer than what you've asserted. So what you have to do is introduce in that equivalent to axiom that the murderer is someone who daydreams and is either
Okay.
illiterate and solves problems, right?
Okay.
That's the way to get the facts about what people are doing up into the murderer class.
That makes sense. Okay, thank you.
Okay.
Okay.
So in here,
Murder daydreams and as a musician. Either or musician or literate.
Let me see the data properties. Oh, equivalent.
so can I
The,
do I
the
put it in
murder
here?
daydreams, true.
Mm-hmm.
Do I type it here?
That's how most folks have been doing it. So you type dreams, and you can approach the next part in a couple of ways, but it's straightforward to put value true. So value is a keyword. Yeah, value. So it's highlighted purple, so it's like it's part of the back logic, and then you can put and.
Oh,
Then
okay.
parentheses, and then put in whatever you use to describe like plays music. Yeah, and then you'll do the values true thing, and then to get the or, you'll just put or. So
Do we need to put daydreams in like
Yeah.
quotes?
So no.
Quotes.
What you will need to do, unless so you only need to put quote marks if there's like a space.
Okay.
Yeah. And so you will want to open up that bracket after plays music. You want to like get rid of that parentheses, I mean.
Oh.
Yeah. And so the parentheses here are to group the or statement. So
Oh, okay. Perfect.
yeah, you just want to put or there instead of and.
How can you leave with this?
Because your plays music,
Music true or
it's
okay, what was
true,
the
or
murder daydreams?
Either
and
plays music or
reads.
reads.
values true or value true.
Oh, okay.
Then
I'm getting it.
close bracket.
Watching a video about.
Yeah, and then
And problem solves.
there we go.
So
Okay.
Oh, value true.
Value true. Oops. It's a lot of pressure when everyone's watching me.
I know.
Okay, so daydream, value
doing
true,
great. Come
and
on.
Yeah, you're doing great.
and Okay, cool. So
Okay.
now
There.
start reasoner.
I'll scroll down. Let's see. So I think what's getting in the way here is that you've put in an equivalency axiom at the top for murder. So just drop off that Mark or Neil or Bear, yeah. And then
Okay.
synchronize your reasoning.
Are you doing the same thing? You're trying to.
Why wouldn't you need that though to identify? Oh, because you have the instances of them?
Yeah, so what we're trying to do is infer which of them is an instance. And so let's go back to your individuals.
Sorry, one sec.
Yeah, that's all right. So you think about it this way. It's like, oh, did it crash? Oh,
Yeah,
no.
I'm constantly saving reopening. 1 second.
So think about it
Okay,
this
so
way. You're playing a game of Clue.
Mhm.
Like what you're trying to do is take information that doesn't directly reference that somebody is a killer and infer that they're a killer, right? But if you were to, another way to do that is if you like asserted that one of them had killed someone, but then you wouldn't need to infer. You would just know that Werner was a murderer, right? And so what we're
Right.
trying to do is like use this information around, like just descriptions around what sort of qualities the murderer has. And that's how we let the inference engine do its work. So and then it infers that the killer has to be this person because they have all these properties, none of which directly mention being a killer. So go to the individuals tab up here.
Into like everyone in the.
Yeah. And then Barry, click on Barry. So remove him from being a murderer. So don't click that. So this is what I mean. Like you're prejudging and then drop Mark off. And then do the same for Neil and Werner. And then synchronize your reasoner. Okay, now go back to the classics and click on murder and you'll see. Now what was going on there is that you had asserted that Barry was in the murderer class.
Okay.
So you didn't see the little yellow band that inferred it because if you've asserted something, it doesn't highlight as inferred because you just asserted it, right? So you are obscuring the result by asserting that he was in the class. What you really want is to know that he's the only one in the class.
Okay.
Does that make sense?
Cool. Yes.
Fantastic. Okay, so let me do some summaries. Yeah, it looks like everybody got it. Very cool. So some highlights. When you're looking at first, like number one here, you're gonna need the individuals, right? Why do you need the individuals? Well, if you take a gander down to line 9, the individuals are the hooks you need to infer line 9. Line 9 should be the thing that you're concluding from lines 1 through 8. What that tells me as somebody who does logic is I really should start at line 9 because that's all I need. That's like the base. I need to work my way up, not from the top down, from the bottom up. And so I introduce the first thing I do, introduce a class murderer. And then I look at daydreams, musician, literate, solves problems. And I take a gander up at the rest of these. Now, here's a kind of like a little litmus test or a little rubric or heuristic you can use. I see daydreams, I see musician, literate, solves problems. I do not see any reference to an instance there. I don't see a specific instrument. I don't see specific problems. So when I look up here and I see that Mark plays a violin, and then take a gander around, I don't see any reason to introduce a violin. All I need to know is that he plays an instrument. That is, he's a musician. And the only reason I would need to introduce a violin is if Mark playing a violin was somehow linked to something else that led to him being a musician. Or I could just say, because he plays a violin, he's a musician. Which is what we did with the data type properties. The difference there being, I didn't need to introduce an object property which would link Mark and instance to a violin instance. I just need to represent the fact that Mark plays an instrument, data type property, true or false. Does that make sense? Great, go ahead.
So in this case, you have a clear objective
Yeah.
through line 9. And you can kind of see it's even almost in a logical shape. So it's kind of easy to understand what you have to do. Are there cases where you are kind of just throwing the net and hoping you catch something?
Absolutely. Absolutely. Most cases are like that.
What do you do in those cases? Because if, let's say that I do not have 9 and I just have 1 to 8, if I don't know whether representing the plays the violin in its completeness with the object property, the value, and so on and so forth, is gonna be helpful or needed for me
Yeah.
to get to the question that I'm trying to answer.
This is a great question. So here's what I do as a logician when I'm exploring a domain like this. When I do not have a stated conclusion of this form and I'm engaged in exploration, I start with granular or high level representations like data type properties, true, false. You can get a lot of information inferred that's valuable just based on data type properties, true, false, just like this. Now, I then look at the inferences. I represent things in certain ways and see what falls out. I run a reasoner and see what's concluded. What can I infer? I also add new instances, see if that changes things. I add new functional properties. I add new transitivity. I play around when I can, but I usually start at that kind of granular level because that gives me like a bit of a lay of the land of what's potentially inferable. Then if I haven't found what I want, I've usually at least got a better idea of what I might be looking for. And then I start introducing object properties that relate instances to instances, because I perhaps have seen that I need to link to more granular or more fine-grained information to infer interesting things. Now, I've given you, this is like super high level for a reason. The work is very creative. It's a very creative endeavor. What you're talking about is like hypothesis generation where you don't know what you're looking for. I don't have guidelines. There are none. It's cool though, right? It's fun. Like that's part of the burden and part of the battle. So now that said, I guess I shouldn't say that there are no guidelines. Here's at least one. Usually as I'm working through some like logical exploration of this sort, I do start with data type level, and then I go into like object property level. I start asserting things like 9-9 to see if I can prove them. I start testing what can be proven. So I start coming up with logical statements and then I represent them and I see if I can infer that information. I'll give you an example. So when I was working on BFO's axiomization, I wanted to like the axioms, when you're dealing with an axiom set so large, it's hard to manage it all in your head at once. I was using like some theorem provers of the description logic and then first order logic sort, but I had like things I wanted to test to see if they held, like, are there infinite loops or generated chains that like go on forever, like force a reasoner to go on forever? Turns out there were in the initial axioms for BFO, there was a parthood relation for processes that required like an infinite loop of process parts. So I have in my head when I'm investigating these sorts of things, like looking for descending chains, I have axioms that I know how to write. And I like line 9 here, and I say, can you prove that this axiom set exhibits like an infinitely descending chain? And so if I get a yeah, I got a problem. I got to find out why. If I get a no, good. But I have stuff like that. I look for formal properties of relations like functionality, transitivity, reflexivity. I look for whether they're inferred. That gives me an idea of the sort of like edge structures that link nodes together. I also look for things like dissectivity of properties, like or dissectivity of classes in relata. So here's what I mean. So if an object is located at some spatiotemporal region R, is it also located at any proper subspatiotemporal region of R? If so, it is dissective on that argument, right? If not, it's not dissective. That's a very interesting and useful formal property if you're trying to do geospatial tracking. So now I have like a test bank of these sorts of things that I run. I also have a debugger on my repo that I made that looks for problematic axiom sets of the sort of like a descending loop or a descending chain. But that has been born out of time and investigation and knowing what to look for. So again, in answer to your question, some guidance. There's like some data type level, there's some like granular level, but like roughly speaking, you start high and then start getting more granular as you go. And there are some resources out there that I'm happy to share with guidance on how to deploy these when you're exploring data sets or just exploring the logic underwriting. Does that make sense? Okay. And also I need help if you have any more. This
Are you
debug.
gonna make that list available for your quick hits?
It's public
Like-
on my GitHub repo. It's
It is.
under
Okay.
something called, I think it's under debugger or logic.
Debugger.
It'd be like logic something. Anyway, it's a cool script. It generates a little it the way I'll just say how it works real quick. So it ingests formal axioms of any size, like a set of any size. And what it does is you tell it the number of axioms that you want it to focus on. Like you could say, just do 10, just explore 10 of them at a time. And what it does is it then randomly selects from the larger axiom set just 10. And then it runs through them to see if it can generate a consistent model. And if it bogs down and doesn't do it over a certain amount of time, then it takes a proper subset. It removes one axiom and it tries again, and removes one axiom and tries again. And it does that until it gets a model, and then it goes back and evaluates the ones that you excluded to see basically which of the axioms were problematic that either led to inconsistency or just a loop. This is my way of getting around decidability problems. Because I'm just debugging. And what happens is, as a result of this, is if I get a loop or an inconsistency, the inconsistencies generate the tool will generate a graph, a heat map, and it'll show which axioms cause inconsistency. They're like beet red. And then it'll give a heat map or a distribution of the axioms grouped together with varying degrees of redness. The redder they are, the more likely it is in that distribution of axioms there was a loop. And then I use that to turn around and fix the axioms, test it again to see if I fixed the problem and avoided a loop. This is a debugging tool that is sorely needed. It's on my repo. You're welcome to go play around with it. I don't have any documentation for it though, so it's like what I just said. There's it uses the TTP. What is it? It's TTP thousands of theorems for thousands of provers syntax. So TTTP. So it uses that syntax. This prover 9 is another. It's the same sort of syntax. It's like Prolog style. But if you're familiar, go check it out. If you want to contribute, do that too. So anyway, yeah.
You can be pretty bare bones about what you enter in.
For this problem, yeah.
Yeah.
Not for the zebra puzzle.
No, not for the zero puzzle. Like I only have like murder as a class.
Yeah. Yeah.
But I'm curious, does the size of the ontology, or is it the size, or is it like I guess what you're trying to like, how would you decide when and when not to use like a swirl rule for it? Because you could use, or you could just put the reasoner. So like, in what like you could use a swirl rule for this.
You could, for sure. I usually use swirl rules when I need to do, when it's clear that I need to do chained reasoning.
Okay.
That's not explicit. So if it occurred to me at some point that I would need to get to line 11, and to get to line 11, I had to go through not just lines 1 through 9, but then line 10 that wasn't explicit, then I would need to use lines 1 through 9 to get to line 10, and then use line 10 plus 1 through 9 to get to line 11. And so if I saw that, then I would know I'd need to do some chaining, and swirl is one way to do chaining. You can also do it with pellet. Pellet has like an incremental reasoner where it'll generate stuff, add triples, and then generate again. So you can do it kind of that way too. But yeah, that's like my heuristic for that. Do I need to do chained reasoning?
Okay. Or when we were doing like the negation stuff, like the Mills method.
Oh yeah, that's a swirly stuff.
Swirl, but could you do that just kind of by like exactly how we did this?
For some of the cases, and it's an interesting exercise to see which ones. If you're doing the first two, then I think you can do it with just this. But I think when you start getting into covariance, that requires some chaining.
The covariance being like
It's like
murder, line 9.
Well, it's more like the degree to which this food caused illness.
Okay.
Yeah, that sort of thing. And we'll talk about that later. He's talking about a Mills methods exercise where I show you how to represent Mills methods for like investigating the causes of certain things using description logic. One other thing I wanted to highlight. So I saw many of you introduce classes other than murder. So you didn't need them. As I was talking to Robert, this is a rule of thumb you should always keep in mind. Is if you're introducing something, anything in your ontology, you need to know why. You need to have an explanation. You shouldn't just add stuff. Like, period. If you're in the wild, if you're in the real world and you're adding stuff, it costs money and time. If you add something and you don't need to take it out, costs money and time. So you need to pay attention and be careful about what you're adding. And so this came up because I'd asked some of you, like, why did you add a class? And you were like, I don't know. Like, that's never a good enough answer, okay? So you should have an explanation. That will also guide you into getting to the answer. Like, if you're looking at this, like, the reason you added anything is right there. Now, so that said, so sometimes you might look, well, like some of the reasons you might introduce a class. Introduce a class when you need some kind of flexibility, like existential flexibility between what's being represented and what could be represented, what's implicit. So in this case, we introduced the class murderer because even though we had instances, we didn't know which of the instances was the murderer. We don't need that sort of information for playing a violin or being a musician. There's nothing about this problem that says, what if somebody is a musician and blah, 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 right? In this case, though, what we're saying is, what if somebody is a murderer and has these properties? Who is it, right? We're not trying to find the violinist. It's right there. We're not trying to find the musician, right? We're trying to find somebody who's a musician with all those other properties. And you don't need those classes to get there. Does that make sense? Yeah. Well, what's up?
So why do we need the murder class? Because it seems like, not that it seems like, I don't know. It seems like we made like a bunch of data property assertions for each individual. And
Yeah.
it seems to be enough.
So the question is, why do we need then the murderer class? Because you have all the data type properties associated with the individuals, right? Okay, so this is a good question because the answer highlights that, again, machines do exactly what you tell them and no more. And what are we looking for? The murderer. You could drop the murderer class and just inspect each of the individuals, and you can say which of them daydreams and either is a musician or illiterate or solves problems, and you're going to find it's Barry, right? But then you just did the reasoning. The murderer lumps all that together, that class, it lumps all that together so you can just push a button and it'll generate the answer for you.
Like, have an individual of a murderer and then say that that murderer has those things, but like we say that, hey, tell me which individual is like murderer individual.
Sure.
Does that make sense?
Try it. Let's try it. So the task now. So Jisoo said, couldn't we just introduce an instance murder? And it was saying the instance murder has all of these properties, right? And then to do this, drop the murderer.
An individual that is not disjoint.
That's not disjoint, yeah. Because what's going to happen is you're going to try to infer that, say, Barry is equal to this person. So what you need to do then, drop the murderer class and then introduce an individual that has all of these features. Let's see what happens.
So the task was just remove the murderer?
Yeah, remove murderer class and then just introduce an instance that has all the features of murder. So we're basically taking the structure of the class from line 9 and just making an instance.
Yeah.
Oh, is that right? Let's see. Can you write it out?
How would you even do the is either a musician or literate part of it, you know?
It should end up if you could represent this, it would be equivalent to do the same as there.
I was trying to cut and paste it, but
Yeah.
so you suspect not murderer?
I don't know. I used two different words just because I was like, so I can keep them separate in my mind. I just type suspect instead.
You just put them under data.
Suspect is either a musician or literate. I don't even know how you would say like because it's Boolean, it's like true or false.
So like,
It can't be.
so you
It
got
can't be.
suspect, right? So close that real quick.
Oh.
Okay, so you got data type. Okay, all right, you're doing it right. Sorry, go ahead, keep going.
Oh,
My bad.
I was like, what? So I don't even know how you would say
Uh-huh.
either is a musician or it reads because you'd have to dictate true or false, and you would no longer be able to use a Boolean data type.
Yeah. And it turns out that the asserting data type properties, like the way you're doing it, they're interpreted when you add many of them as and.
So never or. Okay, cool.
Yeah. Is there any other way to do it? Let's get creative. Is there a way to introduce a data type property that's called reads or plays music? True. I mean, of course there is. True, false, and then you could say,
Yeah, who would
PR would be.
well,
just
then you'd
in
have
the
to,
label.
yeah, that's right. The information would just be in the label. So if you wanted to tease it out and like make the logic semantically explicit, you'd have to figure out a way to connect the data type property reads to that. And then you'd also have to connect the data type property plays music to that disjunction. And then the question is, how would you do that?
Could you just, if you have that double category, wouldn't you have to go through all of these other individuals and say, yeah, technically they do fall into this category or they don't, true, false for that extra one?
So you should just need, like the proposal in here is to introduce a new category that's musician or literate. And then like have that asserted of this individual so that you can say they daydream and musician or literate and solve problems. But then the question is, how do you link solve or playing music to that disjunction as a data type property? And how do you also link reads to that disjunction as a data type property? So then you'd be exploring and looking through what resources you have to connect that new data type property to those old ones. Because you got to connect them.
Can you mess around with like subproperties?
Try it. So think about the logic. If I say P or Q is a subproperty or if I say it's a subproperty of R, what does that mean?
Everything that applies to this applies to those two. Okay.
What's the other way? Right? The pairing, like the property that if you think about the pairs, they go upright. So subproperty means if XY is in this child, then XY is in the parent. It doesn't mean if it's in the parent, it's in the child.
Oh, right. Sorry.
You could try to make a data type property that's equivalent, right? So if you go back, data type properties, you could say music or read, you could say equivalent to. And but as you can see, go ahead and click OK. Well, you just said it's equivalent to itself. Oh, it plays music is equivalent. So what you've done here though is like it's only allowing you to make one equivalency statement, right? And if you do it that way, then you're just going to be able to make conjunctions because they're interpreted. Anytime you introduce a new line, it's going to be interpreted as conjoining them, not disjoining them. Dun dun dun. So you've taken us on a wild excursion in the land of formal logic and disjunctions. So typically, just some essay here. Play around more, see if you can figure it out. But like typically, like the reason that these the conjunction is the standard interpretation of linking things together in this manner is because disjunctions introduce complexity, like computational complexity. Anytime you introduce a disjunction, you're introducing another branch that has to be checked. And so folks in the community building protege, folks in the community who are worried about reasoning, they're scared of that. They're frightened of trees. They're frightened of many trees. They hate forests. They're not eco-friendly at all. They try to stay away from them. They don't want to go through. They don't want to do graph traversal if they can help it. They want to collapse things because they're afraid of the undecidability. And so they don't really allow you in this tool to make assertions of the sort, at least in that avenue that I was suggesting a moment ago. Now, maybe there's a way around it. I hadn't thought much about it, but to answer your question, can we do this? Not for this problem. Not obviously for this problem, but you can do it with a class structure as we've seen. All right, let me move on and share my screen.
What's that disjunction of like murder? I don't even, some example does not possess property, whatever. Like this disjoint.
Say that again. Say it one more time.
What was the point with the disjoint thing? Was that for data properties?
So I was pointing out that in the protege editor, when you're adding, like when we tried, for instance, add like or data type property assertions to that new individual, it was like it made us do it line by line. And same when we were trying to add equivalency axioms to the data type property, it was making us do them line by line. And the line by line is interpreted as conjunction. So this line and this line and this line and this line. Okay. What we need to represent is this line or that line. Gotcha. And the default is conjunction because it takes the intersection of trees rather than disjunction, which introduces new trees. Okay. Yeah. That's the intuitive idea behind it. Thank you. Okay, can you guys see my screen? We should be on Sparkle and DBpedia.
Yes, we can see it.
Delightful. Okay, just a reminder what Sparkle is. It's this not so cleverly named acronym. Sparkle Protocol and RDF Query Language, Core Semantic Web Tech, and Query Language for RDF, and a protocol for transmitting queries over HTTP. I gave you an example straight out of the Common Core Ontologies repository. Here's the rundown, right? First, we declare a namespace when we're writing Sparkle queries like prefix. Then we declare return variables. What do we want to see? Values. This values clause means the type is a variable. This type in blue is question mark type, a variable that ranges over everything in the brackets. So it kind of like recursively iterates through and checks those things, which is to say that for any resource is an OWL class or an OWL object property, return a resource, and that optional thing is saying even if the definition is missing. That sound familiar? I know I'm going fast. It's because I'm going to do this again and again and again in this lecture until it's beaten into your brain. Or is missing, there's that filter, or is missing an XSD English language tag. And then indeed keep only the results that don't have a definition, which is to say that English definition is unbound because it's empty, and ignore blank nodes and format the results with the description of the error. That was a lot, right? Riddle me this. Go forth and play. I won't let you play for too long on this one, but try to answer some of these questions real quick. Remember the deal, go to DBpedia, play around with their Sparkle endpoint, put together some queries, just try to answer some of these questions. Remember from last time, you were able to click on some things like hyperlinks, explore the data set a little more to see which object properties or data type properties you could be pulling from. If you're, as Michael is doing, go ahead and take a screenshot so you can look at this, or take a photo if you don't have it. These questions are different from the ones last time. So, all right, let's stop. Here we go. Back to the thread, homies. Let's roll. We'll come back. Now I want to talk more in depth about CCO quality control and Sparkle checks in your project. Recall. This is the GitHub repo for Common Core Ontologies. There's the structure. You see some folders, you see some licenses and make files, etc. These are just files. I recall also the workflow. You have a main branch and a develop branch. and you have forks on it that change the develop branch. And when a certain number of commits are made to the develop branch, or a certain amount of time has passed, we just merge that develop branch into the main branch, and then we cut a new release. So why is this important? Well, we're using GitHub Actions, which are running like builds and tests and drafting releases for us in a bit on automated fashion, that leverage make files and leverage like all this nice cool stuff, including this tech in the background, including robot from the OBO community. The things that we are most interested in for this course are the part of robot that runs Sparkle queries to verify or check, like the ontology files that are being edited on a develop branch or on your forks, and then ultimately in the merge, while we're creating releases. So this again, this messiness is what you see when a build is conducted or a run through in the background, where anytime somebody makes a change and pushes a change to develop, like this sort of process kicks off and a bunch of quality control checks are run, including like consistency checks and stuff. You'll see here that Sparkle is used in the workflow to run specific, like targeted quality control checks against the database or against the ontology artifacts. As you see here, I'm illustrating that this Sparkle query that says every entity must have a minimum one English definition has 86 violations in the Common Core files, and it tells you which ones, right? Like the Common Core ontologies has ant object property is missing a definition. And you could click on that link and it will take you to an XML representation where you could see just that. There are several quality control Sparkle checks already in the workflow. We need more, which is what your project is about. But before we get there, I'm going to explain to you some of the quality control checks that we have and highlight some of the features of these. And then I'll give you some guidance on going forward in constructing different quality control checks. Okay. So right here, this one, no multiple inverse object properties. So if you have an object property that has an inverse, we don't want it to have more than one inverse. So as a rule, if like has part is inverse continuate part of, we don't want has continuate part to also be inverse of something else. It would lend itself to a lot of like loops in symmetric pairs that we just don't need. And it's very likely you just get by in almost every case. I've never seen a case actually where it wasn't true that you just get by with one inverse. So we have a rule, don't introduce multiple inverse properties for a given object property. But at the very beginning of any of the ontology files that you're looking at in the Common Core repository, and really ontology files more generally, you're going to see at the very top, specifically if it's written in Turtle, which that better be, you're going to see a list of prefixes used. So here's a list of prefixes used. These are the prefixes, I forget for which ontology in the Common Core, but you'll see, like you can copy paste this stuff directly into Sparkle queries. And you can use this, right? So always, if you open up the file, you can find this here, like right at the tippy top. So in that prefix owl, right? Like right at the top declared, if you'll note, it's right there. It's in the list. You don't have to memorize it. You just copy and paste it. Now, in this property, or I'm sorry, in this Sparkle query, what I'm wanting to do is match anything that bears that owl inverse of to some object property. So what I do is I say, take some variable property and assert that it's out and look for one that has an inverse of some other property. And then do that twice. But then I also have to assert, or well, to illustrate, accomplice in Common Core has owl inverse of has accomplice. Now I'm going back and forth between the Sparkle query and the file on purpose, because this file right here is what the Sparkle query is targeting. And you got to be specific about what you're saying or your query won't work. So if I write in a Sparkle query, it says, return anything that bears owl inverse of to something else, accomplice in will be returned because it bears inverse of to something else, as you can literally see in the file. Does that make sense? So of course, I'm looking for things that object properties that have more than one inverse. And so while I've asserted that property L inverse of property 1, property L inverse of property 2, I also need to assert or just want to keep those cases where they're not the same object property. That is, property 1 is distinct from property 2. Without the filter, it's going to return a lot of, or like multiple cases where property 1 is the same as property 2, which is to say accomplice 1 would come back. I'm sorry, accomplice N would be returned, even though it doesn't have 2 inverse of properties. It still satisfies the condition, right? If you interpret as accomplice as satisfying both property 1 and property 2. So you have to say no. They have to be distinct. I just want you to return those. Does that make sense? Okay. And the exclamation equals just means not equal to. Now, union, what I just said, with this other clause, which says, given some property 1 and given some property 2, the two of them relate to some single object property. So the first clause was, does a single object property inverse or relate through inverse of to 2 others? This one says the 2 others inverse of relate to 1. So I need both sides. I need to check both directions. And I also need to make sure that property 1 and property 2 are distinct in this clause. And remember, the union just says, find those things in the first clause and then aggregate them together with the things in the second clause and return all of that. Just group them together. And then, of course, the rest is this binding stuff that I want it to return error, object property, return that whatever satisfied question mark property has more than one inverse, return that as the variable error. Does that make sense? Despite the fact that I had misplaced some of those slides. Does that make sense? Darn it. All right, let's try this again. And hopefully I got this one straightened out. So another one of the quality control checks, no duplicate labels. No 2 ontology elements shall have the same label. We don't want that. Bad, boo. It's rather similar to the last query, if you'll note. I have an element that has an RDFS label. I have a second element that have to be distinct that has an RDFS label. And then I don't want blank nodes here. So filter those, get rid of them. I have that exclamation point, no blank nodes. And then, but I'll leave you with this, by the way, puzzle. I said most of this was the same as in the previous example. Perhaps you should ponder whether the previous example should also exclude blank nodes. Maybe you should wonder why I didn't. I wrote these, by the way. So, food for thought. Now, a little more interesting, perhaps, but not really, because it's very similar to what we just looked at. This time we're looking for definitions, no duplicate definitions. You see in some of the pattern here, we don't want recurrence, repetition, these are like streamlined queries, like simplify, simplify, simplify. We don't want multiple occurrences, more of the same. Okay, this is where those other slides should have been, because now I'm talking about an ontology proper. So this is a little different. Ontology title required. An OWL ontology must have an RDFS label. And this is not true of all ontologies ever in the world. This is true of Common Core ontologies. It's one of the principles we adopt. So all of our ontologies have to have an RDFS label. So what you're doing here, again, as I said, that IRI at the top, I want to vary at the tippy top that says RDF, right under it says RDF type OWL ontology. That IRI in green, Common Core ontology, SMID, extended relation ontology, that is the node that identifies the extended relation module of the Common Core ontologies. Everything in that file is linked through that top node, that top IRI to the rest. It is a type ontology. So that's how you know that the thing you're talking about is an ontology. It has all these annotation properties. Like I said, version IRI, imports, rights, license, comments. What we're looking for is this annotation property that says RDFS label, extended relation ontology. Now, again, this is useful information. This tells you how to extract the label from the file. You need a query to match that structure. IRI, that thing at the top, RDFS label, something. And that's what you see here. Although I will note, just kind of a bit of a term of art here, that there's an A there. Whereas if you remember in the previous slide, it said RDF type. This just says A. Well, RDF type is sometimes abbreviated A in Turtle. Question mark resource A owl ontology means question mark resource RDF type owl ontology. See, that's what that means. Yes.
You don't have to be explicit about creating variable.
Not for, wait, what? Yeah, you do. What are you talking about?
Well, I mean, to make it a.
Oh, no. So it's an abbreviation as part of the vocabulary.
Okay.
So it's like the background vocabulary. Editors understand A as RDF type. So you don't have to worry about that. Yeah.
Is this working for every serialization of our?
Turtle for sure. It works for many of them. I can't say for sure all of them because I hate some of them and I just refuse to engage with them. I doubt it though. I'm pretty sure XML doesn't. I just because why would it? It would make it easier. And so I assume they don't. But for your knowledge though, you can type just for RDF type, you can replace it with A and it's fine. And that's what was done in this query, right? In addition, so I say, pick out anything that's an ontology. I don't want blank nodes, of course, but also match all the ontologies that don't have blank nodes, but keep only those that lack an RDFS label. So filter not exist, resource RDFS label title. You can read filter as saying keep everything in parentheses. You can read filter not exist as saying keep everything except what's in the brackets. So owl ontology, no blank nodes. Keep everything that doesn't have a label. You get it? So filter, you should read when you look at a filter, you're saying keep this stuff. When you say filter not exists, you say keep everything but this stuff. Does that make sense?
If you already have your results, which you're only getting ontologies here.
That's right.
Because it's our ontology.
Yep.
Why do you need the blank node filter thing?
Because sometimes
Ontologies which are blank nodes?
not in the repo proper. Kind of. There used to be. Sometimes there are. Depends on version. It's a versioning thing. We'll see. We'll encounter it later. But sometimes we have like placeholder files during like diff checks and stuff like that have that
So
type.
An entire ontology could be a blank.
Well, the entire ontology could be identified but with a blank node. Yeah. Yeah, it's not great, but sometimes you want an alias that doesn't like specifically identify an ontology proper. You want kind of flexibility in your reference. But we'll get there. But in any event, you get the logic behind filter and filter not exist. It's very important to keep in mind.
So filter is positive, you're grab and
Keep that stuff, yeah.
There, and then the inverse for not exist.
So, well, the other way, right?
The opposite.
Keep what you see here. Keep everything but what you see here. Turn your gaze towards the screen. You'll see that one of the other quality control checks we have is that an ontology element should have at most one SCOS pref label for language highlighted. Lang is a function you can use in filters, among other functions that you can use in filter. In this case, to test whether a language tag exists, i.e. whether it's like tagged on to the end of a string. So, for example, is disrupted by, in Common Core ontologies, has a SCOS pref label, is disrupted by, wait a second. Is disrupted by, it is in fact the same SCOS pref label. Feel like that could have been different, but whatever. Regardless, this is okay. The pref label can be the same as the label. The language tag, or what's being sought out here, is a language tag in Turtle that follows quote marks and an ampersand. So you see, is disrupted by a quote and EN, which is the English language tag. This is what that lang function is looking for, that kind of ampersand syntax with one of the predefined language tags that you see like EN or IT or MAD or something like that. This filter clause keeps the values of SCOS pref label that do not have language tags. So it wants to return the ones that don't have language tags. Now, of course, if you look a little bit above, however, here's a question for you that you can ponder. Above on the like 2 filters up, you see that actually for the preceding query, I have a resource. It's looking for a SCOS pref label value, SCOS pref label value 2. And then in the filter clause, I'm saying keep the ones where the language tag is the same and the values are different. So that is looking for more, and putting in another way, language like the SCOS pref labels that are different with the same language tag. Because we don't want that, so we want to be alerted when we see them. Now here, the next line is getting rid of blank nodes, but then I'm saying filter again on those values that are not empty. Why filter on empty tags after filter on values with the same tag?
So filter on value with same tag does not filter any tag, is it why you have to do it?
So would I return, putting this another way, if I drop line 17, would I return, what would I return? I'll ask you that. What would be returned if I dropped line 17?
Also the stuff which has no language value.
Would that satisfy the proceeding?
For the reverse, the only ones that have tags.
So it's a question worth exploring, right? As you're playing around for stuff. This will help give you an insight into how this stuff works. So you can drop the line 17 and see what happens. It's a good way to figure out how these things work. Like, is it the case that if I identify SCOS pref label with one value, SCOS pref label with another, I filter on just those that have the same language tag but different labels, and I'm removing blank nodes, am I also going to create or like return a bunch of empty pref labels? Would that satisfy the preceding constraints is the question. Ponder away. No extra annotation white spaces. This one's a little tricky because it's messy mostly. This one involves that regex, the regular expression feature of filters. So you can use regex, and this is how I'll show you how to do it within filter in a minute, but regex is a function that lets you kind of inspect the interstitial spaces of strings. You got to be real precise about what you're looking for. So here's an example of what that quality control check is looking for as problematic. So CCO is cause of, if you see in the definition here, there's a definition, and at the end you have an extra space after the variable and period. Extra white space. We don't want that. So what do? Well, we look for annotation properties. And then we remove the blank nodes, we filter on those, and then we introduce this regex function. And we say the string value, namely the value of the property, and then all that garbage. Well, this is effectively looking for extra white space before or extra white space after the start. Like, so before the beginning of the definition or the annotation, or after the before the period, I think, and then after the rest of the string. And there's an or clause. Those double bars says that means or. You can see that this is starting at the beginning because this has got a little caret, and this says look at the first part. Hash symbol. These symbols have defined meanings in the regex or regular expression syntax. I do not expect you to learn regex syntax. I think it would be silly for you to waste your time. I suspect it would be much easier if you use generative AI or use one of the various regex editors that are available online that help you like see what's being picked out in different strings. You can kind of copy paste. You could take, for example, this, paste it into an editor and toy around with possible syntaxes, and it will highlight what's being picked out by the string or in the string, and you can use that as a way to like identify what you're looking for or like write the right regex. You could also do this in VS Code. It has a regex search feature or regex copy paste feature in addition to its regular search. So don't spend too much time on this, but it is very powerful. Often I will say it is like using regex in these filters is like using a sledgehammer to hang a picture, like hammering a nail to hang a picture, because it's way too powerful for most of what you need. So usually when I see it, I'm like, why? But sometimes you do need it. This is a case actually, annotations, like the white space and annotation, where it does seem like you need something that with that kind of strength. Again, just to remind you of the various filter functions and combinations you can use. So you can do comparisons. Regex has all sorts of filters embedded in it that you can leverage. I encourage you to look them up. You can test whether variables have certain values, like whether they're blank nodes or if they're literals, like strings, or if they're URIs. And also you can combine things and or and not, as you've seen. As you investigate the CCO repository, you'll note that there are not many Sparkle queries being run against builds, and you, in your project, will be providing new ones. You will be contributing, a valued contributor to the community, whether you like it or not. In this project, which you may or may not have seen yet, which is on the class repo. So the Sparkle Library of Common Core Ontologies is what I'm calling it because I was lazy and didn't come up with a cleverer name. But you see, the goal here is to develop a suite of Sparkle queries to run against the build. The details of this are your tasking that is to construct Sparkle queries to be included in the CCO QC workflow, which I've linked to. Ideally, your queries will be added to the repository. I've also shown you where they would be put. This is, if you're interested, this is also where you will find the QC, the Sparkle QCs that I was just showing you. I walked through, they're all there. So this is all in the repo already. Your queries will be ranked in terms of difficulty. You will rank them in terms of difficulty. The lowest 8 will indicate a rather easy one. Super simple. We need a lot of those too, while the highest will indicate a very sophisticated query, something complicated. For our purposes, the more sophisticated queries will be worth more points than the less sophisticated, and you're required to submit enough queries to acquire 100 points according to the following system. 8 gets 0, 1 gets 35, and everything in between. Why? Why in the world, I hear you cry, would you introduce anything for no points? For 8. Why would anybody introduce a super simple one? You have to is the answer. Everybody has to submit at least one level rank 8. That's a prerequisite for satisfying the class. Everything else is over and above. So here's a template. You see all this incidentally in the project page. So I'm just walking through what's in the project. Right, so there's the template. Sparkle queries should follow this format and should end with a bind clause, which is what you've been seeing over and over again. It's the same format I'm using. And the guidance, here's some guidance, some tips for developing these Sparkle queries. Review the existing ones first, as we have done here, so you don't duplicate work. I will add, as Mathilde requested, you should pay attention to what your peers are working on too, so that you don't duplicate their work. So it might be a good idea to work more closely together than you may have otherwise, and you may have in the previous project, as more of a conglomerate or protein mismatch of various individuals. Basically, I'm saying work together. So review the documentation and design patterns to understand the structure of CCO. And I've linked here to them. You could be looking to create quality control checks that say enforce certain design pattern decisions. This can be actually from both BFO and CCO. You, for example, might be looking for a tripartite relationship between information, what concretizes it, and the bearers of it. That's a design pattern. It's built in to Common Core. It's built in. It's supposed to be built into Common Core, certainly built into BFO extensions. It's part of the design. So there may be quality control checks that look for that sort of thing. You can also have quality control checks that look for roles being realized because they should be realized. They should.
Oh, they can exist even if they're not realized, right?
But that's the instance level, not the class level.
Okay.
Awesome.
So are we committed to having for each class, which is a role, also corresponding role process realization
Yeah.
class?
Yeah,
And
bro.
the same goes for the information stuff.
That's the design.
Okay.
That's the logic, man.
No, I'm fine with
We
this.
got to make it
I think it's
explicit.
gonna pop up so many.
I know. I know. Part of this is to clean up CCF. Your QC checks aren't going to, they're not going to make, in many cases, some of them are going to make a lot of errors and violations come up. That's not your fault. You're the evaluator. But it does help us fix it, right? That's what they're for. Those 86 violations that I was pointing to, but like lacking definitions, we didn't know there were 86 definitions missing. It's okay. This is part of the process, right? In addition, you understand common issues in ontologies, but you can explore this OOPS list for inspiration. There used to be a tool up there where you can run ontologies through. I don't think it's up anymore, but you can in any event look for the quality control checks that they're leveraging, and we could have parallel quality control checks for Common Core. So that might be a source of inspiration for QC Sparkle checks. Also observe the annotation conventions that are being used, like the use of labels and comments. Make those explicit. Remember, machines don't know how to look for this stuff by themselves. You got to make it explicit if you want to enforce a constraint. And when creating queries, I'll say start with simple ones and then build complexity. And feel free to leverage generative AI, and feel free, i.e., I encourage you strongly to work with each other so you don't duplicate effort and you can learn from one another. And be sure to test your queries before you open a PR. And you can do that in Protege or in the Sparkle Playground, which I've linked to as well. Doop. Here's some more info. If you're looking for the queries, they're under this .github, which will take you here, and you can see Sparkle right there, this Sparkle folder. And you can see things like I've been showing you, minimum 1 English definition. If you click on it, this is what'll pop up in your screen. Said review documentations and design patterns, explore OOPS labels, Sparkle Playground, and your turn. Well, I guess any questions, comments, concerns, compliments. I know I'm looking quite good today. Go on.
So when you say we should work in groups, everyone has to still get 100 points
For sure.
individually.
Yep.
With queries or
Great question that I hear implicit in what you're saying. So when I say work in groups, and also you will be graded individually, I mean, I want a trail of your work on your repo. I want to be able to look at your repo and see what you have done and how you worked with people. You see, I dropped a link or dropped a message in all of your PRs saying, show me where you reviewed. I couldn't find where you guys were reviewing things. And then I was like, if I grade this without knowing the review, some of you are not going to do very well. I want to see how the cake was made. So this is the point, right? You talk to one another, but I want to see all the iterations and the steps on your repo. That's version control. I want to see that stuff. I want to see when you change. I want to see when you update. I want to see your conversation. So make it all there so I can see it, because I don't know what you're doing otherwise. I could trust you, but I don't. Because you're liars.
So I have an instance on my GitHub where when I go to my VS Code and I'm interacting with it, I see the comments that you've left and I see the comments that other students have left. But then when I'm looking at it online, I'm not actually able to find where those comments were left.
Interesting. I think let's Can you share your
So
screen?
could that be part of the issue? Yeah, I can
I
share my
mean,
screen.
I doubt everybody has that issue because I doubt
Oh,
everyone's using VS Code, but I think I know what you're talking about. Can you share your screen? And I think I can help with this.
okay, can you see this?
I can.
Okay, perfect. Let me go to my first assignment. So yeah, so down here I have I have two comments from
I
the
actually
student.
saw that. I saw
You
yours.
did see it. Okay. I couldn't see it on the GitHub website, so I was wondering if that might have been it.
If you go to your the PR on the main branch.
Okay. PR on the main branch. Yeah.
And so,
Sorry, I have to move some things.
all right. So yeah, go to yours. Scroll down.
Oh, okay. So
There.
you would look through them here.
Yeah,
Okay.
yeah. I actually go up a little bit. You'll see. Go scroll down. Not scroll down. So yeah. So you see, you were the only one I gave feedback on because
Oh,
I can see your comments.
okay. Okay, cool. I just wanted to make sure. I didn't know if there was
Yeah.
something that I was doing wrong with it. Okay, cool.
This is what I'm kind of looking for. Like, well, here, let me. You can't see this screen up here on top.
So every time that I make a commit, like I've been leaving like pretty bare bones comments, but would you like me to like elaborate more? Be like, hey, this is a summary of what I tried to do.
Rating's not a bad idea.
Okay.
Yeah. So like you should think in terms of the following. So I don't know what you're doing.
Right.
I need you to explain as explicitly as you can to me and yourselves what you're doing so that I can easily track it. This is the sort of thing you'll be doing in the real world, working in this environment. Like you will have some very busy person overseeing your work who just doesn't have the time to really get in there and like figure it out. And they will just like look at it for a minute. And if they don't immediately get it, they're gonna send you a message that says, "What are you talking about? Guess what happened?" When I looked at your PRs, most of them, I said, "I don't know what you're doing. I am very busy." Now, of course, this is my job, right? Like, so I'm not like saying I'm too busy to review this. Of course I'm not. Like I'm going to, but I do want you to have that thought, right? How I need to be more explicit.
Okay, so leaving because when I like I'm more used to writing code and then leaving like comments in the code using like the pound symbols. So you prefer comments for the commits better. Okay, cool.
Okay.
Just to clarify.
Personal preference. I have to now dig through your code and look for these pound keys. I know they're different colors, but no, either way, actually. I mean, if you're doing it that way, I'm fine with that. I can figure that out. I see it, right? I'll see it and I'll be
Right.
identify what you're doing. So if that's the way you do it, I don't mind. I just play it. I personally just find it aesthetically displeasing, but I'm not going to hold you accountable to that. You might
Well, I could just copy paste them into the commits. Like that's not a
like
big
an
deal.
extra step, but I could just look at it. It's fine. Either way, I'm not like I'm not bothered either way.
If the first week we have to create a PR to our own repo and people comment on that, that is done. When I went through all the comments, I have to create a new PR to your repo. How are you gonna see the comments? Because that's what happened.
You gotta push your comments. You gotta push all that to mine.
So the same PR, I just push it towards yours.
Yeah. So the one that you have comments on, you push to me. I want to see all the comments. And that's what I was looking for. So when I was going through the PRs, I was like, just not review. I know you did. I was just like, I think, yeah. I'm not sure where the reviews are. I even poked around some of your repos, and then I was like, this is too much effort. I shouldn't do this. And at least one of you didn't seem to have any reviews, which it was nobody in this room. That didn't make me happy at all. and may be angry. You know who you are. Don't do it again. There's nobody on this call, but you at home listening, don't do that again. And please ask me, who is this person? Ask me questions. So I've just required as part of the project that you contribute to this major Common Core Ontologies repository, like actual genuine contribution, a value contributor. People are gonna know your name, etc. Fame and fortune, Price is Right. I don't know, Bob Barker. I'm just doing stream of consciousness now, but you are welcome to ask me questions about like getting started, about like what you should focus. If I have any ideas, I might.
What are your ideas?
I have plenty. Okay, so you could look for like there's some quality control, low-hanging fruits, I would say. Like you can check for things like if there are interpretations of familial relationships, for instance, that say things like people should have only at most one father. Logic, the owl logic doesn't enforce that kind of constraint. You could say that all you want. You could say like, but if you assert, for example, that John is a person and all persons have only one father, and Robert's my father and Giacomo's my father, and owl reasoner one further the same person. Not that some error has gone down. So you could write a QC check that said, for this object property, it has at most one value. Stuff like that. You could do some other low-hanging fruit, like you could check that certain annotation properties that are conventionally associated with IRIs are always there. Is it the case that, for example, any ontology file has a license? You remember what I was showing you on the screen, like the extended relation ontology IRI, and I was showing you that like it had annotations like license, imports, stuff like that. All of those are required. Like every ontology in the CCR repo has to have a license, it has to have an import declaration, has to have a label, has to have, right? Description. And you might look at the 11 files and say, well, John, they all have it. That's not what you're checking. What you're checking is if somebody forks the repo, does some changing, and then pushes it into develop, did they make any changes that violate the conventions for the repo? You could easily fork the repo, change the extended relation ontology by, say, dropping the license, like annotation, then push it over, and somebody could miss it if they're checking it manually. What we want is that they get an error immediately before it even goes to develop that says, you missed the license. You have to have a license on this so that I don't have to go check that. Does that make sense? So things that you see that are done right in the ontology files, we have to enforce that because who knows what's going on in the Wild West? And I don't want to have to go through and check all that stuff every time somebody makes a push, right? Does that make sense? Should I say it again? I can say it again. Happy to.
So just make sure that is included when you're pushing it through.
Yeah, check it out. Here, I'll say it. I'll show you. Just to be crystal clear. If you're looking in the extended relation ontology file, you'll see near the top that IRI at the top. You see then in green, you'll see it's a type ontology. And then it'll have OWL properties like version IRI, imports, rights, license, label, version info. Okay, so we want Like that, this is good, right? We want that kind of information in the file. So here's something that I don't want to do though. If somebody forks the repo and makes a change to the file, like for example, for whatever reason, maybe they accidentally delete DC terms rights. Say they accidentally delete that. And then they go push to the development branch. I don't want to have to check that. I might miss that. I might say, yeah, that's cool, and like just let their push go all the way through, even though they just deleted an annotation property that we want to keep, like the rights declaration. So instead of forcing me to like have to manually go in every file, every time somebody makes changes on anything else, I have to check this stuff too. What we want is to have quality control checks, and like in this case, using Sparkle, that checks that anytime you have an ontology, it has these annotations. And so if you've done it correctly, if you say have a Sparkle query that says any ontology has to have DC terms right declaration in the Common Core repo, then if somebody accidentally deletes that on their branch and then pushes it over and tries to merge it into develop, they will get an error before it merges. And it will say, hey, you don't have a DC terms rights declaration, which is to say, fix it if you want to merge. So I don't have to do it. They can fix what they dropped. And then those sort of quality control checks, I don't have to do manually. That's kind of the goal here. What we're doing is trying to automate as much of these checks as possible because there's a lot to check. Does that make sense? So again, the guidance here is even if you see something done well, like done correctly, if you're looking at the file and you're like, what do I check for? Could I check for logical relations of the sort that I was describing a minute ago, like person has at most one father? Or should I even what should I be checking for annotation properties? The answer is all of it that you can. But it's totally fair game to enforce the good cases that you're seeing in the files right now, because who knows what's going to happen out in the wild when people are making changes on their own forks. Okay, got it? Sweet. I've inspired myself. And my hand is up. This Zoom feature where like your hands get like it does the finger, like I gesticulate too much. It's like I'm always like raising my hand or thumbs up or something, I guess.
So, Tim, since you're here, I'm going to ask you.
Yeah.
You're familiar with CCO.
Yeah, a little bit, yeah.
Okay, so going to John's example of the has one father,
Yeah.
I'm looking through this code and I'm looking through the agent ontology turtle file, and is that where I should be looking for how CCO defines father?
No, I think he's saying it is the relationship itself, right? So you want to check
Yeah,
for what?
but depending on how you define father, like a person can have more than one father.
Mhm.
Like, are we
Right, but I
talking?
think it's the singular parent, right? Right, so that's the rule that you're checking. You're not actually looking for John's father.
Mhm.
No, what I'm saying, can you necessarily enforce that like an individual can only have one father, or is it saying that
I was given an example.
Yeah, right. I
no,
mean,
no,
are
yeah,
you
but I mean
are
using
you
that as
saying
like
like
a basis.
you can only have one parent class? Is that what you're?
I was saying, so if you wanted to enforce that somebody had at most one father, then that was the way that problem got up, right? Like got off the ground. And you might say biological father, right? To make it a little more precise. Does that make sense?
Yeah.
Mhm.
Okay.
But here, I'm gonna show you something. I'm gonna show you how you might search to target.
Because I found it, I just like control F and I found like
Gotcha. And so I'm looking here, you can see my screen, yeah.
yes.
So that's a web page. Oops. If you go to the repo, GitHub has a pretty good text search, right? So if you
Ooh.
searches through the repo, so it has father right there. And you can click on the file, like it'll take you over to the agent ontology, take you right to it.
Perfect. That's exactly what I'm looking at. Awesome.
Good. So just for all of you, right? Like you can leverage the GitHub repo search. It's pretty good. It text is very like string heavy, so like it looks for the thing.
Now, do each of these have definitions associated with them, or descriptions rather, that are not here? Like, how can I find that where CCO defines father as?
Ah, so father doesn't look like it's here. It doesn't look like there is a father class.
Oh, okay.
Agent ontology representation of the relation has father.
I have a question.
Yeah,
Can you?
I can hear you. What's up?
So I understand you want us to go through and see all the queries that were written before. How complex is complex?
Ah, that's a great question. So that's a question we should all investigate. So Obi has asked a very good question. How complex is complex?
Yeah.
What's one? What's eight? Like what does this mean? You will show me. It will be a rank order based on the complexity that you provide.
Can you give us like a
reference?
No, absolutely
What
not.
What about
What I will do
you
is I will
provided
look
us?
at what's that?
You provided us with a link, and inside that link, it gives examples of what is a critical task, what is important, what is minor. Could we use that as a basis?
For sure, for sure.
Okay.
But what's going to happen is when you're in the results that you produce, I'm going to look at the most complicated one, and I'm going to look at the least complicated ones, and I'm going to use that to rank everything else. That's how you should think about it, because you should definitely think about it that way, because you might not have 100 points if you don't. So part of
But
this exercise is to think through on your own how complicated is complicated. And the only context you really have are the QCs that I gave, and then the QCs that you make. So, yeah.
but from that answer, it means that one person can tip the scale and leave everybody in the dust.
That's true. It's good to point that out. So maybe we should avoid that from happening, right? Maybe you should not let that happen as a team. So Obi has astutely pointed out that somebody could really screw everybody up by creating a super complicated query, right? And like drops everybody else's points because the ranking has just been skewed. So like as a team, you shouldn't let that happen, right?
So the benchmark would be the most complex
Mhm.
query.
Yeah.
So, or.
Yeah, it's almost like you should really work together.
But it's not about.
It could be. That's one way to be complicated.
This is kind of the reason I'm asking is I write a lot of query, and complicated for me could be a very, very joint
Uh-huh.
like
Sounds like
complex.
you're gonna skew the ranking.
I'm not
You guys gotta watch out. Obi just told me he's gonna skew the ranking.
I'm not gonna skew the ranking. I'm just asking because if there's a benchmark for everybody to like me,
Mhm.
then because a complicated query for me would be me like using a cascade upon a
Mhm.
cascade upon a cascade. Just three
That's
cascades in a query will make it very complicated for people to follow.
Yeah.
So how then do we um balance this out?
Again, by working together. Let me show you. I'll show you. So to your point, Obi, to your point. So let me show you what something I consider complex.
We have to check the complexity of every
Okay.
query.
Here.
Like put people in a room and make them battle.
They're online, we can.
Wait.
So here is, can you see my screen?
Yes.
Okay, let me show you. So let me show you something I consider to be a complex query. So this is a fixed point query. So what is a fixed point? I suppose I should tell you that. A fixed point, here's an example. So a fixed point, here's how you might calculate it. It's like closure under entailment that after repeated entailments, like generation, just returns the same set of individuals. So you don't get, at some point, basically you bottom out, and anytime you run run a query, you return the same results. And so like if you, for example, have an assertion governed by modus ponens, so that anytime you had if X then Y and X, you get Y, and you ran it over here across this, at some point you would bottom out and generate the same set, which is this. Now, what is that? You can write a Sparkle query that does the same thing. And in this case, I'm running a query over this set of individuals, Bart, Lisa, Mira, and Samantha. And the query will just return, I'm sorry, that will be the result. But here's what it's running over, this little data set ancestor of with Bart, Homer, Lisa, Marge, Mira, and Samantha, where I've asserted Homer as parent of Bart, etc. If you run, and then what I'm looking for is if I were to run this parent or this query here about ancestors and descendants, is there a point at which I just get the same set of individuals back anytime it's run? And there is, and this is how you find it. This is a very complicated query because it involves a sparkle with and multiple sparkles embedded in multiple sparkle select queries, right? Like, so you see, I've used select several times. I'm running selects inside selects inside selects. Putting all that another way, if you, one way to get complicated is if you're running essentially multiple select queries within the same query and then unioning them. That's pretty complicated. This took me a while to make, right? It was a very valuable query to have. I wanted to know fixed points in my database. And also, there were papers published that said you couldn't do this in Sparkle. And I got upset because I was like, you absolutely can do this in Sparkle. And so I did it in Sparkle. And anyway, I don't know if you know this about me, but I hate it when people say you can't do stuff. You can. So if you're looking for like a litmus test for some complexity, I would consider this, if not one, and close to it.
So
Not to say that yours has to be less complicated, but go ahead.
how many people in this class? 15?
Sounds like it. Yeah.
So we have to cross-check 15 repositories.
I think only 8 people are submitting work.
8?
I think so.
Yeah. I haven't turned in my
Oh, 9.